In this lesson, we're going to talk about combining like terms. By the end of this lesson, you should be able to identify a like term, and you should be able to simplify expressions by combining like terms. One of the things that we like to use to help us gain an understanding of what a like term is and how we combine them is through the use of models such as algebra tiles. So if we were going to model the following expression, x minus 4 minus x, what we would need to understand is that in our algebra tiles, these long rectangles down at the bottom, they represent our x's. The giant squares would represent our x squares, and the smaller squares would represent our constants that we have at the end. Yellow in this case would be positive, and red would represent a negative. So in this expression, I would use one yellow rectangle to represent my positive x. I would use 4 red ones to represent my negative 4. I would use 1 red x to represent my negative x. And I would use 2 yellow ones to represent my positive 2 or my plus 2. So this is how we would represent x minus 4 minus x plus 2. Now, we want to combine like terms. So what we do is we combine terms that are similar. So any x's that I have, any rectangles we would put together, we would group together. And any constants, any ones, we would group together. Now, the important thing to note when we're combining like terms is this idea of zero pairs. Zero pairs are opposites. So when we have two things that are opposite one another, such as our positive and our negative x, they form what's known as a zero pair. And as you could imagine, the zero pair is 0. So it means that it's gone. So here we had a zero pair. The x's now went away. Here we have a zero pair. And here we have another zero pair. And what we're left with is now our expression. So we're left with 2 constants, so this expression would be negative 2. All right, and let's model one more, just to see if we have a true understanding of what's going on. Now, let's look at this one. So here we have x squared minus x minus 2x squared plus x minus 3. So remember, anything that's positive is yellow, and we have our 1x squared here. We have a minus 1. We have minus 2x squared. So I'm going to have 2 of my negative x squareds plus x, and then minus 3. So minus our 3 constants. I get my 3 constants. See if I could drag them at the same time. Lost a couple on the way. It's all right. All right, so here is my expression. So we are going to now combine our like terms. So all my x squareds go together. All my constants go together. And I only have 1x, so there are no other like terms for that one. And then remember our zero pairs. So if we have any zero pairs, which we happen to have here, we have a positive x squared and we have a negative x squared. Those can make a zero pair. And when they make a zero pair, remember that they disappear, they go away, because 0 is essentially nothing. All right, and then what we're left with is our simplified expression. So here we have a negative x squared plus an x and minus a 4. So like terms have to be the same variable, and it has to be raised to that same power. Okay. So, a variable, coefficient, and a constant. We need to kind of understand this when we're talking about like terms. The variable, this is a letter that represents an amount that's unknown, and this amount can change depending on whatever situation that we're looking at. Your coefficient, this is the number that goes in front of the variable. Remember that the operation that's indicated there is multiplication, and your constant is a number that doesn't change. This is a number that's at the end. Usually it's being added or subtracted to the number. It doesn't change because there's no variable attached to it that would cause it to change. We're talking about like terms. Like terms are terms that have the same variable and it's raised to the same power, and they're on the same side of the equal sign. So when we're talking about an equation, they must be on the same side of the equal sign. So same variable raised to the same power, so it has the same exponent, and it's on the same side of the equal sign. And then all constants are going to be considered like terms. Remember, constants, these are the terms that don't have a variable on them. All of those are going to be considered to be like terms. Okay. An expression and an equation. Okay, we do need to kind of know the difference between these as we're talking about like terms. An expression, this is a expression that doesn't have an equal sign. Because it doesn't have an equal sign, it can't be solved, and all you're going to be able to do is combine your like terms. An equation, on the other hand, does have an equal sign, and it can be solved for a specific variable if you're only missing one variable. Let's practice with combining like terms. Remember that like terms, these are terms that have the same variable raised to the same power, and they're on the same side of the equal sign. Well, in our three examples, there is no equal sign, so these would be considered expressions, so we don't have to worry about the same side of the equal sign here. But what we are looking for is the same variable to the same power. So here we have 2x. We want to look at all variables that have just an x, and so that would be these three right here. And then we want to look at what's left. We have an 8 and we have a 5. These are our two constants. Remember that all constants are going to be like terms. Once you've identified your like terms, combine them. Now notice, I've circled the operation that goes in front of that term. So make sure that you're including the operation, because that's going to tell you if you need to add it when you combine or if you need to subtract it. So we have 2x plus 2x plus 5x. So 2x plus 2x, that's 4x, and 4x plus 5x is 9x. Then we look at our constants. Okay, we have plus 8 minus 5. 8 minus 5 is 3. So we have a positive 3. So the simplified expression here would be 9x plus 3. If we're looking at the next one, again, same variable. So anything that has an x, okay, to the same power, so we don't have to worry about that. But we do have to worry about the same variable piece, because we have an 8y and a 4y. Now, the 8y and the 4y are like terms to each other, but they are not like terms to the 9x and the 2x because their variables are different. And then we have our constant hanging out here on the end. We're going to combine our like terms. When we're combining like terms, we want to put our variables in order from an alphabetical order, and we want to put our constants in the end. So we're going to do the 9x and the 2x first. 9x plus 2x, remember to circle the operation, to include the operation in front, that's going to tell us if we need to add or subtract. 9x plus 2x, that's 11x. 8y minus 4y, that's positive 4y. And then we have the minus 8 that's hanging out here on the end. And so this would be our like terms here. Okay, if we're looking at this next one, before you can begin to combine like terms, you first have to take care of this distributive property that's taking place here. So let's take care of that first. We're going to bring everything else down that's not a part of that distributive property. That way, when we finish with the distributive property, we can jump into combining like terms. Remember, distributive property says to multiply the number on the outside by both of the terms on the inside. So we have 8 times x, which is 8x. 8 times 1, which is 8. We have 2x times x, which is 2x squared. X times x is x squared. Minus 6x, because that's going to be the 2 times the minus 3. And then we have all of the other terms that are there. Now we're combining like terms. Remember, we're looking for same variable to the same power. So if it's x squared, the term has to have an x squared. Then we have our x's. These are not like terms to the x squareds because they are not squared. Again, remember to include the operation that comes in front. And then we have our constants that are hanging out here on the end. We've got 2 of them. Now we want to combine. Okay, when all the variables are the same, remember that we're putting them, we want to keep them in alphabetical order, but we also want to keep them in order in terms of power. So we want highest power to lowest power. So we're going to do the x squareds first. We have 2x squared plus 2x squared. That's going to give us 4x squared. So we've checked those 2 off. Then we have our x's. We have 8x minus 6x, so that's 2x. 2x minus 4x, that's negative 2x. So we have a minus 2x. So we've taken care of our x's. And then we have our constants, 8 minus 8, which is 0. So we don't need to write that one. Okay, simplify. We want to simplify, so we're going to use the distributive property here, and then we're going to simplify. So here we have 5 times y and 5 times 2. So this would be 5y plus 10 minus y. Keep in mind that we have like terms of 5y and y. So this would end up being 4y plus 10. Again, we're distributing, so we have the 3 times the 3x and the minus 3. So this is 9x minus 9. We have our 2x here. We're going to combine our like terms. So 9x plus 2x, that's 11x. And we have our minus 9 that's hanging out here by the end of it. We've got our last one. We've got 7 times 3m and 7 times 5k. So 21m plus 35k. That's minus 14m. This is plus 12. So those 2 things didn't change. And now we can combine. Again, we're keeping it in order from an alphabetical order. So the 35k, which is by itself, should come first. Then we have our m. That's 21m minus 14m. So that would be 7m. And then we have our plus 12 that's hanging out here at the end. So it's plus 12. Okay. Finding the perimeter. Again, we can combine like terms when we're combining the perimeter. I can either write it all out or I can look. And again, we're going to circle all of our terms that are the same. So we have 2x, 3x, 2x, and 3x. So this would be 2 plus 3, which is 5. 2 plus 3, which is 5. And 5 plus 5. So 2 plus 3, 2 plus 3, and 5 plus 5, which is 10x. And then remember we have our 2 constants here, 2 plus 2, which is 4. So the perimeter of this would be 10x plus 4. Remember that it's an expression, not a numerical answer. When we have a word problem, you're doing the same thing. So we have, suppose you buy 3 shirts that cost X dollars each, jeans for 30, and a pair of boots for 50. We want to write the expression. So you could write X plus X plus X plus jeans for 30 and boots for 50 equals, and we don't know how much it equals, we just have an expression here. Or I could combine my like terms, and so this would be 3x and this would be 80. Okay. Remember that like terms, just as a reminder, like terms are terms that have the same variable to the same power or same variables to the same power. So if we're looking at 3xy squared, any term that has an xy squared, so this top one, this bottom one right here, those would be considered like terms. If we're looking at x, any term that has just an x, so like 1/2 x or negative 4x, would be considered like terms. When we talk about x squared, we got negative 3x squared, negative 2x squared, and we've got -5, or we've got positive 5x squared. All of these have an x squared. And then we have two that we can't look at. They don't combine with anything because they don't have the same variables to the same power. Although this has an x squared y, this other one over here has an x squared and a y squared, and there are no terms that have an x squared and a y squared. All right. Before you watch the next video, I would like for you to consider what a like term is. So like terms are, and as usual, please subscribe to our channel so that you can get updates when new videos are posted.